Good morning, everybody. Last week, I think we stopped at this point or somewhere close to here. Maybe I should start from a little bit back and see if you have any questions. We said that, of course, we are writing functions in C++, like C. And the way we write functions are very similar. First, we give the declaration of the function. What is the declaration of a function? The name of the function, the return type, and the parameters and their types and their order. That's it. The names of the parameters, okay, are not within the definition of the function declarations, because the compiler doesn't need to know the names of the parameters at this point, because I am not implementing the function, right? I am just declaring it. I am just telling the compiler that I need two parameters. One of them is the integer. The first one is integer. The second one is double, and that's it. It doesn't need to know the name. The story is different when you are implementing it, because when you implement the functions, of course, the compiler needs to know these names. Okay. So for convenience, for some reason, the author of this book included the names here, because you usually talk about these parameters. Okay, it says that I have two parameters. I have this number parameter and the price parameter. Okay, that's the explanation of the function. I mean, it is just for human convenience. It is not for the compiler. Okay, so I did this. I wrote my main, and I call this function. Okay, I call this function, no problem. Then at the end of this file, I included my implementation of this function. This is what we saw last time, and maybe I think I stopped here, and maybe I talked a little bit about this picture here. We said that usually we like to keep our functions in a separate file. Why? Because we like to hide our implementation from the customer. Customer need to see only the header file. Within the header file, you have the declaration of the functions and the other definitions, such as the structs and the constants and etc. Right? So when you look at the header file of string.h, okay, you will see the definition, okay, not the implementation, but the definition of the string class, okay, and the implementation of the string class is hidden somewhere else in a library, and you don't see it. You don't have to see it. You don't need to see it. Okay, so we hide that kind of information from the customer, even if that customer is yourself. Okay, you don't want to remember how you have implemented that string class, because that will only confuse you. That will only make the things worse in terms of designing new classes or new functions. Okay, and technically we are compiling these two files like this. I compile file.cpp, it produces an object code, file.o. I compile the tc.cpp, tc, remember, includes that function in it, and it produces this one, and I link them together, and that will produce me my executable program. Okay, I mean, you don't have to do it in this order, or you can do it all together using a single command line code. Okay, just compile everything and link. You could do that. For example, I would do this from time to time. I would do this g++ star.cpp. That's it. Okay, so that means that compile everything in this directory and link it. What would be my executable file name? It should be a.out, right? A.out is my executable program. That's how G++ or GCC compilers work. But usually we don't prefer it this way, because for large projects, let's say you have 20 people, okay, working on this large project, and there are hundreds of C++ files in it, And suppose one of the developers made a change in his file out of these hundreds. You don't want to compile everything, okay? You like to compile only that file and link it, right, to run your program. So if you do this, that's not a good thing, right? I mean, you're compiling everything. You don't want to. So compiling it one by one is a better idea, but you might say that for 100 files, this is not good. Am I going to type all of them together one by one? No, you don't. Instead, what do you have? You have the make files, right? Did you learn about the make files? Okay. They told you about the make files. You know about the make files, and I think I will ask the TA to make a problem session about the make files and the libraries and etc. Maybe debugging. And that's how you do the things in the Unix environments usually. Things are not that difficult, but we like you to know what is going on at the fundamental level of these compilation and linking processes. Okay, good. So if I move on, we said that, okay, function declaration. Okay, compiler needs to know only the return type, function name, parameter list. Okay, instead of giving the name, it is just sufficient to give this line, just double, total const, int and double, that's it. Okay, so it doesn't include the names. But the problem with this one is, of course, when you are documenting it, because we usually document our functions, put comments in it, we cannot talk about these parameters in a convenient way. I mean, they don't have the names. How should I talk about now? I mean, I should maybe say, I would take the integer, multiply with the double. That doesn't sound very good, okay? And if I have two integers, then what am I going to call them? Okay, arguments versus parameters. Maybe I was going to skip. I plan to skip it, but maybe I should talk about it. Okay. Usually we intermix them, arguments and parameters. But the right thing to make is, okay, formal parameters and arguments. Okay. In function declaration, these are parameters. Okay. When you are calling the function, we call them arguments. Okay. These are parameters. Okay, parameter, function parameter, formal parameters, but these are arguments. When you call them, we call these, when you call a function, okay, line 14, we call these two variables our arguments to pass to the function. But when you are implementing these functions, these are the parameters, formal parameters. So that's how we name them. That's the right way to use it. But usually people use them interchangeably, okay? That's something to know, okay? Okay, function, of course, called functions, other functions, and including the main. Main, of course, whatever we did up to this point, we always called some functions from the main function, okay? And somebody is calling main too, okay? Somebody is calling main too. Who is calling the main? Since main is a function, somebody has to call it too, right? Who is calling the main? Yes?
Compiler.
Compiler doesn't call any functions. Compiler just compiles it. It produces executable code with the linker. Compiler doesn't call anything. Yes? Operating system, yes. Operating system calls the main. When does it call it? It calls the main function when you give the request. On Windows, when you double click on your executable program, on Unix, when you type its name on the shell, command shell, your main function is called. If you like, you can call your main function within the main itself or from some other function. That makes it recursive. We don't use it usually. I mean, it is okay to have a main function like this, main, and I am calling int I main, okay, and return 0. So this will run into a infinite recursion. In a while you will run out of stack, okay, because this is not anything useful, but it is possible. So since main is a function, you are calling it yourself, okay. Not a useful program, but just to show you. Okay, so we will talk about the recursion, and you talked about the recursion in your C classes. Later we are going to talk about it. Okay. Void functions are possible actually, and void functions are the functions with the side effects, as I told you last time. They don't return anything. They just take these two values and they do something with them. And whatever they do, they don't return anything. So usually their job is to show something on the screen, to write something to the file, to send some data to send some data through the internet, through the network, and etc. Okay, if they are not returning anything. And again, I am not going to talk much about these void functions. As we said, in this case, show results takes these two parameters and prints them on the screen in a formatted way. Usually, I like to include this return statement at the end, even though you don't have to, because it's going to return anyway. But this makes it clear. Okay, I am not returning anything. This is a void. Okay. Return statement, it just transfers control back to the calling function, etc. We know about these. Skip it. Okay. When we write a function, okay, when we write a function like this, a function declaration, see this semicolon here? It's a function declaration. After the function declaration, we write our comments, okay, saying that in order for this function to work, precondition should be, okay, balance is non-negative, and rate is an interest rate as percentage. So you would expect the rate a percentage, so it should be a double number, and balance is a money amount, so it has to be positive. And postcondition is, okay, postcondition is amount of interest on a given balance at given rate is done something. So this is, before you call this function, you have to satisfy this, and these are the things that this function does. This is what you are promising to the customer of this function. Okay, and sometimes you would call these inputs and outputs of this function. Well, it looks like this function is a void function. Maybe I mean, since its name is show, it just shows it something on the screen, I guess. So this is the custom. After each function declaration, you put these. Okay. If you think about this, if you think about the header files, since we include our function declarations in the header files, if one of your customers is reading the header file, he or she will see the function declaration and the comments about your function. So they know, your customers know everything about how to use your function and what that function does without looking at the implementation. Okay. Attendance. Let's start from this end. Okay, don't hold it. Okay, just pass it. And I need that attendance back in 10 minutes. Okay, good. Main is a special function, I know. Yeah, we talked about this. Okay, and who calls the main? And we talked about the operating system. Actually, I mean, more than the operating system, within the operating system, there is a special process which is called shell. Okay, shell is a special process that runs on the operating system. For Unix environments, it is usually a shell like this. Okay, when you ask the operating system, what kind of programs are you running now? PS. It says that PS is running. Of course, I just run it, and bash. Okay, bash is a shell. Okay, it's a kind of an interface between yourself as user, typing user, and the operating system. So the responsibility of bash is taking these kind of commands and sending it to the operating system. Okay, that's one thing. So that's for the Unix environment. It's kind of a shell This is just a command line shell, command window. It happens like that. But for Windows or those kind of graphical operating systems, the shell is different. For example, for this machine, the shell is Explorer. Okay. Do I have the Explorer somewhere? Okay, this one, this one. Yeah, where is my Explorer? Do you see it? Let me sort it by name. Yeah, I have sorted my name. Do I see Explorer? Maybe it is in the processes somewhere in the details. Yeah. Yeah, here it is. Okay. Explorer is the shell process. Okay. It's like a process like the Teams or OBSS, whatever I am running here. It is just a process. Its job is act like an interface between the user and the operating system. So the correct answer to this one, I mean more correct answer, of course operating system is correct, is the shell. Shell is calling your main function. Okay? And if there is no main function, your linker cannot produce an executable program. It has to be a main, there has to be a main function. Okay, and that main function is called, in this case with bash, when I say run this function hello, and it produces this message, this program, hello world, and whatever that main returned, you could get this with this statement echo $? You remember that, right? We did this before. Okay, good. Any questions so far? And I showed you the documentation of bash. There was a good documentation about it. And I think I showed you a web page that talks about the bash programming, script programming. Just it would be very good for you to read those kind of bash programming or any kind of shell programming pages. Because, I mean, bash programming, shell programming will make you much more efficient developer. I mean, you don't do all of your tasks using just writing C programs or C++ programs. If you have many of them, if you need to use some utilization programs, okay, then you need to put them together, and shell scripts are usually very good ways of doing that kind of stuff. Okay. Any questions so far? Okay, if no questions, let's talk about the scope rules. You already know that, okay. We like local variables. Okay, local variables are they are declared inside the body of a given block, and their definitions are available only within that block. Okay, within that block. Okay, if you have a block like this, curly bracket starts and curly bracket ends. I have an integer declaration here, and I'm incrementing the value by 1. So this green bracket is the scope of this integer. This integer is valid only within this bracket, green bracket. Okay. How about this function f? Okay, I have a function f. As expected, each function should have at least one block. My block starts here, curly bracket, and curly brackets ends here. I have an integer definition here. Integer is valid within this, inside this green bracket, and double is, let me use a different color. Double is valid within this, okay, red bracket. Those are the scopes. That's the definition of the scope. If I look at this function g, I have 3 blocks in here. The first block is this black block, okay. In that black block, the parameter, okay, k is valid. K has to be valid. The parameter valid k should have the whole scope of the function, of course. But for this green scope, okay, block, only I is valid, and there is another one. Unfortunately, I will have to use the red again. Okay, so inside this black one, parameter k is valid. Okay, k is valid, or its scope is this black one. I is valid here, and this I is valid here, and these two I's, okay, the green, use colors again, the green I and the red I, although the names are the same, they are two different variables. Okay, there are two different variables. So of course you did this kind of stuff in C. This is expected. So these are two local variables, and this is the way to go actually. I mean, this is, if you need I, this integer I, only for these two lines, okay, then do it this way. And if you need this double I only for these two lines, then do it this way. So don't be afraid about using these kind of local variables. Okay, so we try to keep the things local. Why? Because if that I is needed only for two lines, then after that I should forget about it. If I don't forget about it, it might have some side effects. Okay, the changes to I before I use it might produce some results that I did not consider before. So scope rules are like that. They are the local variables, and scope is local, and we prefer the local variables. And we like to make them as local as possible. Okay, so I would choose so that I can maintain the individual control over the data. Okay, I need to maintain the individual control over data, and depending on the need, I declare my local variable, and after it is done, I am done. This is very similar to this. Remember how we use the for loops? When we say for integer I from 0 to I less than some size, etc., plus I. Okay, when we do this, the scope of this I is just within this curly brackets. That's it. After that, I is gone. So we have been using this for a long time. I can make another for loop, and I can use the name of I again, but it will be different than this I. Good. So you already know about the scope rules, and procedural abstraction, we talked about this a little bit. We like functions because they let us apply this idea of abstraction. Okay, procedural abstraction. So what's a procedural abstraction? It's like this. It's like a black box. You have a black box. You know what that black box does, but I don't know how it does it. Like the sign function. Okay, functions are like black boxes. I know what they do because I read the comments. Okay, those are, remember, the precondition and postcondition comments. I read those comments. I know them. I know what they input, their parameters. I know what they output, their return values, return types. But I don't know how they are doing it. This is called procedural abstraction. And we like this idea. In C, we wrote lots of functions. We use lots of functions that are written by other people. Okay, that are written by other people. If you are writing a function, you should definitely know what it does, and it should be clearly commentable. On the header file. And if you are having difficulty telling what that function does, okay, if you are having difficulty telling what that function does, then that means that you made a mistake, logical mistake, because probably you are doing too many things in that function that are not related to each other. So that's not a just procedural abstraction. That's just, we call those functions soup functions, çorba fonksiyonlar. You put many things together, and you are saying that this tastes good, but this, I mean, I don't know what kind of function is it. I mean, it's not a reusable function. Why? Because you cannot tell your customer that what that function does in a few sentences. Okay, So it is not reusable. It is just one-time function. That doesn't make it a very procedural abstract function. Okay, we are after these kind of functions. Abstraction, as I said, is very important for us, for all the engineers, for all the scientists, for all the computer engineers and the software engineers. And we are going to talk about this even more when we start writing our object-oriented code, because object-oriented is all about abstraction. We are going to take this procedural abstraction one more level up. Instead of doing just procedural abstraction, we are going to put our data in it too, and we are going to call it encapsulation. So encapsulation is the abstraction of procedures, the functions, along with the data itself. Okay, so the idea of object-oriented programming is basically comes from the encapsulation and abstraction. Okay, again, this the term information hiding is something we hide all the details of how this sign function works. That's called the information hiding, and we are going to apply this rule a lot. We don't hide the information because we are jealous. We don't hide the information because it's a security issue. We hide the information because it is not useful for the user of this function. Okay, it is good for them. It is good for us. Okay, some people think that we are hiding it because it's a customer, it's a banking data, it's a money data, it's a personal data. No, it is not. Okay, even though I have written it, I am hiding that information from myself. That's the idea of abstraction and information hiding, and we will keep talking about this. As you may have noticed, I keep switching between the idea of object-oriented programming and the mechanisms of doing it, right? So this is kind of difficult. I mean, I have to teach two things at the same time. How to do it, mechanism-wise, in C++ or C, and the other part is why we are doing this, okay? And this is a little bit different from your C language classes, because in C language class, I mean, it was the name, the class is about C language. You learn how the language works, okay? You rarely have an explanation why we are doing this or why we are doing that, okay? We just say that, okay, this is a function, functions are declared this way and we are used this way. Now we start to talk about a little bit more about the theory, why we are doing it, and also we are talking about the mechanisms. When you come to this programming languages course in your third year, they will never talk about any mechanisms of doing things. It will be all theory. It will say that, okay, functional languages, okay, procedural languages, object-oriented languages, and etc. And they will seldom give you any example programs. So we are kind of in between. So this slide, as you see, did not use any coding examples, but it is talking about a very important topic, okay? Procedural abstraction and information hiding. Yes?
In object-oriented programming, we put abstract keywords, but in C, how they keep abstract?
This is what you did actually with the sign function, okay? When you use a sign function or square root function, you are applying procedural abstraction. You are using somebody else's black box, okay? And when you have written functions, actually they did not tell you, but you applied the idea of procedural abstraction. Okay, you wrote functions of yours, right? Some function with a nice name and with a nice explanation. That's the idea of procedural abstraction. And if you wrote it good enough, okay, designed it very well and commented it very well, put it in a header file, then you end up with a reusable code, right? Somebody else can take your function and use it in their own programs, or you can do it yourself if you did it right, okay? So functions are the first examples of procedural abstraction, and it is available in C, okay? Of course, it is available in C++ too, but C++ makes it a little bit, takes it one more level up, and it introduces it introduces this encapsulation idea, and we are going to talk about it. I mean, maybe I shouldn't say C++, I should say object-oriented programming languages. Information adding, abstraction, encapsulation, these are the things that you are going to hear a lot in this course. Okay, global constants and global variables. As you see, I crossed out these global variables. We don't like global variables in object-oriented world. Actually, we don't like global variables in C programming language either, because if you use global variables, it is possible, okay, but they are seldom used because they are dangerous, no control over usage. Let's say I have this global variable here. Let's say I have this prog.cpp. I have nice includes, and I have a global variable size whose initial value is 10. Okay. By the way, this size is initialized before the main function is called, right? So don't think about your main function as the first function to be called. Before your main function is called, this variable is initialized. And think about this. How about this one? When you say f2, in order to initialize the size, the function f has to be called, right? So I have to initialize this global variable before the main, but to initialize size, I have to call function f. So f is called before the function main. So if anybody says that the main is the first function to run in a C or C++ program, is wrong, okay? I mean, as in this case, f is called before main in this case. Okay, so let's say size is initialized to something. I am going to make it back to the original, okay? And I have this function f. It modifies the value of the size as 7, and I have this function g, okay? And it prints the value of size on the screen, okay? So depending on who is called first, f or g, okay, the value printed on the screen will change. I don't have, as function g, I don't have any control over it. So it depends on the order of what function is called first. And if I have another function h that modifies the value of size again, I don't have the control. I cannot trace it, okay? It is not easy to see what is going on in your program. The worst thing is remember our structured programming principles. What did they say? I can take this function definition from this file and put somewhere else, okay? But this function is dependent on this global variable size, but the global variable is defined in this file. So that's going to put me in very bad trouble. That's not a good thing. That's why we don't like global variables in C or C++. Never use global variables. Global constants are kind of okay. Why are they okay? Because nobody is changing it. It doesn't depend on who is called first or next or that kind of stuff. Okay? Doesn't matter when you call them, okay? Global variables are bad. Global constants are not that bad, because how else are you going to define a constant pi, right? The number pi, 3.14 something, or the constant e. Are you emailing somebody? I guess you are. Don't, okay? I am talking here. If you don't want to come to classes, don't come to classes. Okay? So turn off your computer. As I said before, constants are kind of okay, but globals are not good. Don't use any global variables. Sometimes it is very easy to use them. It makes things right. It may seem that it makes things right, but when your program grows to include hundreds of functions on tens of files, those global variables will make it bad, okay? Will make it bad. So don't use global variables, even though it is possible. In Java, those kind of languages, there are no global files, global numbers. In C, it is possible in C++, but we don't use them. We don't use them. Okay, blocks again are available. We talk about the scope with the for loops, while loops, and etc. Of course, if you have more than one statement, you need to define blocks, and there is a concept named block scope, and I think we talked about that. I am going to skip it and look at this one. Okay, control less than okay plus plus, and this CTR is not valid here because it is defined here and its scope is here, right? Okay, I think previously in the very old versions of C, the CTR was available even after the for ended. Later they have changed it. Okay. Nested scope actually we use it a lot. For within a for, while within a while, and scopes are within each other, and it is possible, and we encourage it because it gives some local scope and it is meaningful. Okay, so that's it for this chapter functions. Chapter number what? Chapter number 3. I'm going to start chapter number 4 now. Any questions? Yes.
Can we declare an integer in if statement?
Well, I mean, if you are saying this, if a Boolean expression, this is a block, right? Just a block. Inside the block, whatever I do whatever I want. You could say integer k 7, of course. This is no different than a while block or for block. Okay, but if you are saying that, can I declare an integer k, and its value is 1, and then a is equal to b, this one works too because I have used the comma operator here, right? But if that k is available after that, I am not sure about. Well, I mean, the first thing, don't do anything like that, okay? This is very confusing. I confuse myself too. Even if, I mean, this will compile too, but I am not sure if this k will be available. I mean, since scope of this k and this k is the same, I might get a compiler error for this one. If I make this an n, then this might work, but I mean, since you asked this question, I didn't know. Don't use this one. Don't use this one doesn't mean that don't try it. Of course, try it. Try to get an error message. But in your real programming life, don't use these kind of statements where it should take more than 10 seconds of a reader, a software developer. That's a bad line. I mean, it should be like simple statements. Read it one after other, because if I am spending some time on trying to understand what this is doing, why it is doing, that's a bad code, because it's thousands of lines, right? I cannot spend that kind of time. So, of course, it is possible, and the example that I give you here should be possible too, but don't expect anything out of it, anything useful out of it. Yes.
Can we only use integers inside the for loop? I mean, when defining the for loop, we are always saying like int I equals 0 or something.
Not equals, assignment.
Yeah, so.
So what is your question? Can we use?
Only be integer, or can we assign a double inside a for loop?
Sure, why not? Those are your statements. I mean, we use those kind of stuff because we usually, with the for loops, we usually count some stuff. Counting is done by integers, okay? But if you are doing something else, let's say if you have a double k, it starts with some crazy number. I don't know where I got this number, okay? As long as k is greater than 0.0, and every time I divide k by 2. Why not? You could do that too. Okay. But how many times do you think this loop iterates? Well, it is not that easy to see, right? But when you look at the integer incremental loops, it is easy to see. It is like 10 times, 20 times. So it is difficult to guess the exact output of these kind of loops because you don't exactly know how many times. But it is still possible. Sometimes you don't care how many times it runs. Because the important thing here is always divide it by 2. As long as it is greater than 0, then continue. Okay? But it is a very dangerous loop, by the way. How many times it is iterated depends on what? It depends on, of course, this value and architecture plus your compiler switches, okay? This double, if it's a 8-byte double, then its precision is something, and how do you get I mean, theoretically, there is no way to get the number 0 by dividing a number by 2, right? If you keep dividing a number by 2, theoretically, in mathematics, pure mathematics, you cannot reach 0, right? It keeps dividing and dividing and dividing. That's what I know. But in computer world, our doubles are finite, okay? There are certain number of doubles available, not infinite number of doubles. And depending on precision, the closest two doubles get together has some limit. It is not infinity, okay, infinitely small. So this one depends on the architecture, the compiler switches, the size of the double. Not a very good for loop, okay. I don't know when it's going to end. Probably it will take a lot of time, and it will depend on the compiler switches, and will depend on some optimizations too, actually. That's a very dangerous thing. So that's why probably you don't see these kind of for loops often. Yes?
Can we get maximum precision, like hundreds of zeros and then one for C? Like,
well, you are saying that maybe don't write this. You are saying that there's not a good condition. Maybe you are saying that 1e minus 100. If you do this, semicolon, so you are not dependent on the precision anymore, because you are saying that it is not greater than 0, but it is, I mean, a number with 100 zeros and then 1. Is that what you are saying? Kind of. Yeah, so what are you saying?
Like some mathematical methods need more precision than C++ can give. We maybe some two double in one to
Yeah.
get more precision. Like
Doubles, yes, they are available, but again, they are finite, right? You cannot represent an infinitely small number, okay? In computers, we have precisions, okay? The mathematics in computer world is different from the mathematics in real life or the theoretical mathematics. We should always, there is a numerical degeneracy, okay? Numerical degeneracy means that although what you are doing is theoretically sound, theoretically fine, correct, due to the precision issues, the code that you are writing is running into these kind of problems. The result that you are going to get is going to be, if you do this 1.0 over 3.0 times 3.0 may not return you a perfect 1.0, okay? Don't expect to get the perfect value out of these, because when you divide 1.0 to 3.0, I mean, you know that number, right? That number has infinite number of 3's in it, and if you multiply it with this one, you may not get exact 1.0. Sometimes you will get, sometimes you won't, okay? Don't write this kind of code that depends on perfect mathematics, because we are not living in that kind of world in computers. That's why, what do they say? Never use doubles to represent money, right? Did they tell you that? Don't use doubles to represent money, because if you keep losing cents or kurush in every calculation, okay, and if you have millions of customers, that means thousands of liras every day. And for a bank, losing or miscalculation thousands of liras every day is a very bad thing, because at the end of the day, all of your calculations, all of accounting should be perfect exactly. Okay, that's why in humans we don't have, okay, we have two Turkish liras and 51 kurush, right? You don't have things like 2 Turkish liras and 512 kurush, right? We don't have those kind of stuff. This is not you cannot have a price like that. It has to be an integer number from 0 to 99, the kurush side. Okay, good. So, any other questions about this? Yes?
We are writing functions before we are writing function declarations actually before implementing them and before main. This is because operating system first calls that function and after that, yeah, like main.
That's a good question. First of all, operating system don't care about where the function is implemented and it is declared, because operating system doesn't see it. Okay, you could have implemented this total cost function at this line 3. Okay, you omit this semicolon and put the implementation here. It's fine. Okay, so you don't have to declare it, then main, then implementation. No, you don't. Okay, you don't. So why are we doing two things then? It makes our job difficult. No, you are telling the customer that the important thing for you is this function declaration. If you are going to use this function, then only this much information is enough for you. Okay, I am giving you the command already, so use it that way. That's one reason why we are doing this. Okay, the second reason, okay, tell me the second reason. Why are we separating this declaration from the implementation and we are putting the implementation at the end?
Readability. Because of the readability.
Because of what?
Readability.
Readability, yeah, well, that's one thing, yeah. But that's kind of, we are saying the same thing. I mean, why should the customer read the implementation if they don't need it, right? Make it more readable. Connected to that, there is something else. What else? If I do it this way, it will be, or somebody is talking from the, I am sorry guys, I forgot about you. How many of you are you there? Where is my attendance sheet? Could you bring my attendance sheet here? How many people are there? Okay, here. They are raising their hands. Okay, 71 people are there. Okay, raise your hands. Okay, out of 71, I have 31. Raise your hands, guys. 45. Not bad, yeah, okay. For an online session, that's good. Okay, so somebody was giving me the answer. Why are we separating the declaration from implementation and putting it in two different places? Thank you.
Because we don't need to know how it works.
That's what we said exactly, actually. I am asking for the second reason. Second reason is this. If I have a file like that, okay, total cost declaration, main and total cost implementation, it would be very easy for me to convert it to this structure. Put the declaration in this header and put the implementation into this implementation file. Okay, so remember, we don't prefer these kind of files, many functions in the same file. We like to keep them separate so that they are reusable. So it is easy to make this factorization, refactorization. You know refactorization, writing your code again. Okay, so I did the same thing again. Instead of doing a 45-minute lecture, I did 55-minute lecture, sorry. Let's take 15 minutes of break. When we come back, we will continue from this point with chapter number 4. Again, I hope to finish it today or tomorrow. 10 minutes. How am I doing with?
Hocam merhaba. Ben yüksek lisans öğrencisiyim de 2 hafta maalesef çalıştığım yerden izin alamadığım için gelemedim. Bundan sonra da derslere düzenli olarak katılmak istiyorum.
Güzel.
Yalnız arkadaşlar bazı formlardan bahsettiler ve hani yoklamada ismini göremedim.
Dersin syllabus'ını bir oku, dersin videolarının hepsini dinle. Onların hepsinden bahsettik, tamam mı? Şimdi sana iki cümlelerini açıklayamam, bir şeyler eksik kalır.
Peki hocam bunlara nereden ulaşabilirim? Hiç yani okulda da yeniyim ben aslında.
Dersin team sayfasına gir, orada syllabus'ı var. Ondan sonra orada zaten videolar da var. Hepsi orada. Dersin team sayfasına gir. Team sayfasının linki de bölümün sayfasında.
Peki hocam bugün yok mu sayılacağım?
Bugün yok sayılacaksın, evet. Danışmanın kim senin?
Güzel yer oldu.
Tamam. İyi de sen dersin 7'de birini kaçırdın ya bu 3. hafta.
Hocam kapatacağım yani çalışarak. izin istiyor. İzin lazım falan diyor. Öyle bir şey mi lazım gerçekten, yoksa hocanın izin vermesi mi lazım?
Hocanın çevresi için dediğim ki yazılımda istediğinde de yazılıyor. Her zaman hoca sana
Tamam.
Okay, chapter 4 is about parameters and overloading. We already know about parameters, but in C++ introduces a new way of passing your arguments to functions. It's called call by reference. Okay, so we are going to mostly learn about this, and then there is this new concept of overloading. And default arguments, they are in C++, and we are going to talk about them. So let's look at this idea first, okay? In C, when you pass your argument to a function, it is always call by value, okay? In C, there is no call by reference. We just to solve this problem, because there is no call by reference, we have this simulated call by reference in C. So we pass a pointer to a function, and using that pointer, we can change the value of some parameter, right? So that's called simulated call by reference, which is available in C and C++. C++ introduces a new way of passing parameters. It is pure call by reference, and this one is not available in C, and we are going to see it. And later, in a few weeks, we are going to see why we need such a new mechanism. It is a little bit confusing from time to time, but it is needed for some reasons, and we are going to look at that call by reference mechanism. Let me show you this picture, okay? Okay, in C, let's say this is the C code, even though I'm using this one, okay? This is the C code. I have an integer I, initial value is 7, and I say that take this I as an argument to function f and print its results. And function f is something like that, okay? It takes k, okay? K is a local parameter now, local value, increments the value of k and returns it, okay? So that's one thing. The g is another function. It takes an integer pointer, IP, and it takes that pointer, whatever that pointer is pointing to, that references it, okay? It increments that value and it assigns it back to this pointed place. So G is in effect doing call by reference on the integer that you are sending, but G doesn't take an integer, it takes an integer address. So G is in effect doing call by reference on G. On J, sorry. G is behaving like it is doing call by reference on J, but in fact what it is doing is just taking a pointer. So it is in fact what in real life is doing is it is doing call by value on some pointer, okay? F is doing call by value on an integer. G is doing call by value on a pointer, integer pointer. So in C, everything is call by value, but the way we use these pointers makes it kind of simulate an integer call by reference. Okay, so in C we don't have pure call by reference, but in C++ we have, and we are going to see it in a few minutes. I think this is clear, right? So here I am sending an integer. A copy of that integer is made. This k is different from this I, right? I and k are different. So whenever you modify k, I will not be modified, right? So these two are just copies of each other. K is a copy of I. I modify the value of k, so k is different from I. But when I do this, okay, when I do this, I send the address of j, which is assigned to IP. So IP is a copy of address of j. I am not changing anything about IP. All I am changing is that I am following the pointer of IP, integer pointer, and I am making modifications to that. And in effect, it is changing the value of j. And it looks like I am doing call by reference, but I am not doing actually. I am doing call by value. Okay, is this clear? And this is how they teach you, okay, how they talk about call by reference and call by value in C. And they made a, I think they made a stress out of this one. Okay, they stress this out for you. They say that this is not call by reference, this is simulated call by reference, right? You look confused. Didn't you learn it this way? Call by value and call by reference, but this is not a call by reference. It's a simulated call by reference. How about you guys, online people? So you didn't learn it this way? Just say or no. Say yes or no. No?
Yes.
So you learned call by reference, right?
Yes.
So you call it call by reference or simulated call by reference? So then forget about that. What you have learned is simulated call by reference. You have been doing call by value, okay? You have been doing the call by value of pointers. But as a side effect, if you follow those pointers, you end up modifying some kind of an integer or double, and it makes it look like you are doing a call by reference. But in fact, what you are doing is call by value, okay? Because when you send the address of this j, you are not changing the address of j, right? You are changing the whatever the pointer points to, that position. IP is not changed. You are not playing with IP. You are playing with whatever IP points to. That's called simulated call by reference. Okay, we tell these kind of lies from time to time, just not to scare you from the beginning of the class. And I am doing the same thing, a few lies. Well, I wouldn't say they are lies, but I mean they are just simplifications, maybe I could say. Okay, instead of simulated call by reference, they told you that it is a call by reference, but it is not call by reference, it is simulated call by reference. Okay? Yes?
What is the call by reference?
I'm going to show you.
Okay.
Okay? C++ says that this is call by reference, and you are really doing the call by reference with C++ way. Yes?
Not good.
Okay? So I am going to do it. With a call by reference, it is like that. Okay? Let's say a function, I have a function g, and I am doing this. Okay? When integer I, let's say 0, and cout I, let's say this is h is ignored. If this one doesn't print 0, then h is modifying the value of I, right? Even though I didn't send the address of it. This is called by reference. Okay? This is called by reference. Why? Because it is modifying the value of I if this I doesn't print 0. And in C++ it is possible, and we are going to see it. We are going to see it in a few minutes. And most of you as C programmers won't like it much. Because, I mean, you looking at these 3 lines, and this is like call by value, and you are saying that this is like call by reference. How should I know that this function h is changing the value of I? And from the looks of it, I cannot say that, but I mean, this is how they designed the language. So we are going to see it in a few minutes. And then we are going to talk about overloading, which is using the same function name, exact same function name, but with different parameters. And then we are going to talk about default parameters, which is the Instead of giving the same arguments over and over again, why don't I assign the defaults? Yes, you have a question?
Yes. What is the max parameter list?
What is the?
Max mixed parameter list.
Well, you could mix call by value, call by reference in a function call. If you have a function with more than one parameter, one of them could be call by value, the other ones could be call by reference.
Thank you.
Okay, let's start. Okay, 3 methods of passing arguments. Okay, call by value, you already know that. Simulated call by reference, that's what we have been doing with C. And now call by reference is the address of actual argument is passed. Okay, so call by value parameters, actual copy of actual argument is passed. Okay, most of the time we did that. Sometimes we don't like this call by value because call by value is expensive. Why is it expensive? Well, it is expensive not all the time, but sometimes. Sometimes call by value is expensive. Why? You are saying so, yes?
Because it copies the same value in memory.
Yeah.
Duplicate.
Exactly. I mean, when you make a function call with call by value, I have to make a copy of it, right? When you make a copy of it, if you modify the copy, the original will not be affected. But copying takes time. Well, you might say that, okay, the integers are just 4 bytes. Why is it an issue to make a copy of 4 bytes? Well, maybe it is not an issue for integer, but if you are passing a struct, and inside the struct, let's say you have 1 kilobytes of data, every time you make a copy, every time you make a call by value with a struct argument, then it's going to take lots of time. So sometimes call by value is not a good way. So for those kind of cases, we usually don't send the structs to the function. What do we send? We send their pointers, right? And even though it is not our intention to change anything yet, we just send their pointers. So call by value parameters, actually a copy of the actual argument is passed, and that argument is our local variable now. And whatever you modify inside your function, you are modifying the copy of that actual argument, and that's why you don't see the changes in the actual argument. And this is the default method for both C and C++, and there is an example. Again, most of our examples are stupid examples. When I say stupid example, I am not saying that whoever writes this function program is stupid. I mean, program itself is stupid because it is very difficult to write something smart, just 26 lines of code. Okay, just a small program to show you the effect. Okay, global constant is kind of okay. I have a function phi. It takes 2 integers and it takes them call by value. Okay, hours worked and minutes worked. Okay, so this one is going to calculate how much money I should pay to my worker. If worker works 10 hours and 15 minutes and my rate is $150 per hour, okay, or per quarter hour, then how much I should pay to my worker. That's what they are going to calculate. And this is my main function, my integers and double, and I get these values from the user, okay, hours and minutes, and I call this function call by value, okay, hours and minutes, and then I print these values out. For many hours and this many minutes, my bill is this much. So whatever the user enters, hours and minutes, this hours and minutes will be the same. This one and this one, these two. Can I do 4 finger points? These two and these two are exactly should be the same because nobody is modifying them, right? So line 18, there is no way that line 18 can modify them. Why? Because my function is called by value. Let's look at that function. Where is that function? Where is that function? Function is here, okay? This function is written in a way that, I don't like the way it is written, in a way that it calculates the total number of minutes worked by multiplies the hours worked by 60 and adds the minutes worked, so that it is calculating everything in terms of minutes. So I divide those minutes by 15 because my rate is for quarter hours, çeyrek saat, quarter hours, okay. Then quarter hours is multiplied by rate and it is returned. Okay, so it looks like line 29. I am modifying the minutes worked. Well, it is okay because I am modifying the local variable. I am not modifying my minutes value at line 18 because I have a local. Usually it is not a good idea to use your parameters to do some calculations, to some modifications. And changing your parameters is not a good thing. So maybe I should have defined another integer saying that integer total minutes or something like that inside my function. But this is just for the, as I said, it's a stupid program, just for the demonstration. Okay, even though I am modifying those minutes worked, I will not see the effect from the calling function. Okay, call by value example. I think you did such an example maybe the 4th week of the C course, the first time you have seen the functions, etc. Okay, so there is nothing new. We already know this, and there is a sample run. Not going to talk much about it right now. Okay, so let's go back and let's try to see another stupid program to see how the call by reference work with C. Okay. Okay, call by value. Okay, I'm not going to talk about this. You already know this. Okay. So call by reference parameters. Instead of talking about in theory how it is done and etc., I will just throw you to the C, and you are going to see it now. Okay. Line 4 and 6. Look at them, and this is just some new notation. Okay. To line 8, there is no difference. I mean, show results. It takes 2 integers and it shows them on the screen. Line 8, just that, right? Okay. Line 4 and 6 are different. Why? We have never seen such syntax before. Okay. It takes an integer something. It is not integer pointer. Okay. It is not integer itself. It is integer ampersand. That means that line 4, it takes 2 integers by reference. Okay. And line 6, it takes 2 integers by reference again. Get numbers and swap values. Okay. The intention of get numbers is to take 2 integers from the keyboard and assign them to input 1 and input 2. Okay. Whatever I send to this get numbers function, okay, whatever I send to this get numbers function will be modified. The integers, okay, will be modified. And how should I call this function? It is just like this. Let me take these out first. Okay, I have first num and second num not initialized. I call get numbers. What did the get numbers do? What does the command say? Function declaration command, it says read 2 integers from the keyboard. So this get numbers will read 2 integers and it will assign the first one to first num and second one to second num. And then I will call the swap values. What does the swap values do? Read the command again. Interchanges the values of variable 1 and variable 2. So it swaps their values. If this one is 3, this one 7, then 3 and 7 will be swapped. Okay, the swap values will swap those values. Again, it's going to change my first num and second num. And show result is our old-fashioned call by value. Okay, so 4 and 6 or 13 and 14 are doing call by reference. It's a new way of passing arguments to functions. And 15 is the old way of doing things. So this is what we call by reference in C++, which is not available in C. Yes?
If we have a vector as a parameters, can we do like this?
You could use this call by reference on any kind of type you like, including the user-defined types, vectors or strings or your own types. Okay, you could take an address of a vector, or you could send it as a reference to your functions. Okay, and sometimes we like to do this even though I don't have any intention of changing this value. Sometimes I send a reference because if you send a reference, there is no copying involved, right? This is cheaper. This is cheaper for most of the data, for most of the types. It is not cheap for integers or doubles because they are already very small. Okay, it is cheap for large data such as the vectors or strings maybe. Okay, good. Another question? Yes.
So, when we change address of parameters, is it safe or not?
When you change the address of a what do you mean address of a parameter?
For example, variable one. We want to change address of variable one.
Well, how can you change the address of a parameter? You cannot change the address of a parameter. I mean, if you have an integer I, how do you change the address of I? You can take the address of it, but you cannot change it. You will okay, that you will have that kind of questions for which I have very simple questions like how are you going to do that? It is okay to get confused because I mean these are different ways of doing things, and I am introducing them, and sometimes you get shocked, you get confused, and it is okay. The best treatment for those confusion is to write code yourself. I mean, I just said including this ampersand and the function header makes it call by reference, right? That's what I said, just a simple sentence, simple character. But when you start writing code, you would get confused. If you write a few functions yourself and try it yourself, that confusion goes away. By watching these slides or watching the YouTube videos will not make that confusion go away. Okay, you have to practice it, you have to use it, and you have to get some errors from the compiler, you have to get some logical errors from your programs. In that case, you start learning about it. So my suggestion after the class, you go and just test these yourself without looking at these slides. Okay, it looks like I didn't show you the implementation. Nobody asked me about the implementation. And the implementation is as simple as this. Let's look at the implementation of show results first, because we already know this. Takes two parameters and prints them on the screen. That's it.
Yes.
Okay, so nothing new in show results. But let's look at this swap values. It takes two integer references, not pointers, two integer references. I have a temporary integer here. Variable 1 is assigned to temporary, variable 2 assigned to the variable 1, and this is our usual swapping algorithm, simple swapping algorithm. Okay? Simple swapping algorithm. So it looks like I am using this variable 1 like a regular integer, right? But when you do this assignment, you are modifying this variable 1. Since variable 1 is the same as, in this case, is the same as first num, you are modifying first num. Okay? Whenever you modify here variable 2, you are modifying the second num in the main function. Okay? Similarly, when you modify input 1, you are modifying variable 1. When you modify input 2, you are modifying first num and second num. Okay? You are modifying first num and second num. Okay? Good, so this is how you do the call by reference in C++. Simulated call by reference is already there. Yeah, we can use it. But usually, if you are going to do simulated call by reference, just for the sake of call by reference, we do call by reference in C++ this way. C people don't like this kind of syntax because, as I said before, I know line 15 will not change anything first num or second num. But when I look at line 14, okay, it is doing something sneaky. I mean, it doesn't tell me anything about, I am not sending the addresses. It looks like I am doing a call by value, but call by reference is happening. I cannot understand what is happening by looking at the function call. So how do I know that it is a call by reference? You need to go to the definition of the functions. The definition of the functions, declaration of those functions will tell you. Okay. Good, yes.
Are there any performance difference when we return a vector from function with call by reference or directly return?
Yeah, returning call by references. Well, it is the same question as should I pass it call by value or call by reference? Of course, call by reference is faster. If your data is large, if your data is integer or boolean or double, it is the same thing. Okay. By the way, what is happening with the call by reference in assembly is exactly the same as passing a pointer and following those pointers. So the compiler is doing the work for you. Compiler is doing the call by reference simulation for you if you are doing this. So the cost of sending a call by reference parameter to a function is the same as sending a pointer. Okay, so this is not any faster than doing simulated call by reference. Maybe it is a little bit more convenient. Okay, maybe it is a little bit more convenient. That's it. Okay, so why do we need this one? You are going to see it. In C, we can't do anything like this, right? Pass, okay, this is fine, right? I could say, I guess the value of FA, no problem. But how about this? FA guess the value of I. Can I do this? Can FA be an L value? Can I use FA in place of an L value? The answer is no. Somebody said from the online audience that I cannot. That's the truth. Okay. How about this? Can I write such a thing in C? Yes. If function f is returning a pointer, an integer pointer, right? I dereference it, which makes an integer, and I make this assignment, right? So this is good for C and C++. This is good for C and C++. In C++, it is possible to write these kind of stuff too, which is good for C++. Because if this one returns a reference, I can make an assignment to the references, and we are going to see it maybe tomorrow. Okay, but this is something dangerous, because if you are returning a reference, it has to be a reference to a variable, and if that variable dies just after you return from this function, then you are in trouble. So it's going to be a dangling reference. Okay, what else? I don't remember what yeah. Remember this? Remember the old days? In C, everything was simple. I know what I was doing. So get numbers. If I use the simulated call by reference, okay. So I would take two integer pointers, I1 and I2, and I would say, give me two integers, and Cn to that reference I1, that reference I2. And swap values work this way, right? I could have done this using the simulated call by reference of C. But instead I did this C++ way. By the way, remember what I think I erased some stuff here. Yeah. Let me try to do this. How about this one? Blue. Swap values 7 and 8. So, what do you think will happen?
Hocam, these are constants. Maybe it can throw an error.
Well, logically, it sounds like, how are you gonna, that's what you're saying is correct. How are you gonna, he said that these are constants. I mean, how are you gonna change their values? I mean, from now on, 7 is 8 and 8 is 7. No, that's not, that doesn't make sense. The compiler should produce an error message. Yeah, that's true. But what is the error message? Error message is this. You cannot get a reference of 7 or you cannot get a reference of 8. Okay? You cannot get a reference of 8. So the compiler will give you error message at this line. No, I can make this call because your data is sending me your arguments is not right. How about this? If I put a const in here, const, again, when you say const, this get numbers function, when you are calling it, this get numbers function will produce an error message saying that first num and second num are constants. I cannot produce references for constants, so it will not work. So if I put a const here, line 13 will not compile. Okay? And it's same as the swap values 7 and 8. Okay? It's like as stupid as doing this. What is the address of 7? Where does 7 live in my memory? The 7 doesn't live in your memory, okay? 7 is a constant. Yes.
If function parameters were constant, can we write?
Well, we'll talk about it. Nobody knows about constant, etc.
Yeah, no, 7 and 8.
Well, I mean, if you're okay, since you asked that, if your function parameters are constant integer references, then you will get an error message here, because you are saying that your parameter is a constant. Now you are changing it. 7 and 8 might work, but your function will not compile.
May I ask a question?
Sure.
So would you rather have us use simulated call by reference?
No. We are doing it at C++ way. Whenever you can use call by reference. Okay? Call by reference. From time to time, maybe we will need simulated call by reference, but if you don't have to, definitely use call by reference, C call by reference. And you should, I mean, if you need to, you should use your call by reference in your homework too. Did you read your homeworks? I had lots of questions from the people during the weekend, on Monday, on Sunday maybe, yeah. Okay. Don't try to be smart when you are doing your computer moves, okay? Just make a random move, just to, I mean, of course, if you like to be smart, you can do it, but we will have a separate homework about it. And there will be continuation of this homework. Your homework is ready, and it will be released, I think, on 28th. It will be continuation of this one, and the third one will be continuation of that one too. But each one is doable by itself. I mean, this is not a very difficult homework. So next time you are going to add some more stuff of it. Okay, I think I used too much time. I will stop here and we will continue tomorrow. And I will see you, some of you, on tomorrow. Okay, bye now.
Okay.